The solution to an inequality is any number that makes it true. We can represent inequalities in words, we can represent it in algebraic notation, we can graph it, we can also list possible solutions, because an inequality, if you remember, is not a single solution, it is an infinite number of solutions. So let's look at our first example on the list here. It says x is greater than -1. So greater than is going to be this sign right here. So x is greater than -1. When we get ready to graph, there's a little trick to remember: open circle, close circle. And this guy looks like he got hurt worse. So this is an open circle on -1. So here's -1. We're going to put an open circle in that one. And x is anything greater than -1. So we're going to extend our arrow out, because it could be anything here could possibly work. So that means that it could be 0, it could be 1, it could be 2, anything continuing. It can't be -1 because it has to be greater than -1, but it could be over here in the -0.5, as long as it's greater than -1. Then we have this one algebraically, m with this symbol -2, and this symbol is less than. So to write that, we would say x is less than -2. So we're going to put our circle at -2. This is our anchor point right here. If it is less than -2, it cannot be -2, but it can be everything less than that. So we're going to extend our arrow this way. So x can't be -2, but it could be -2.5, -3, -4, -5, any of those. -3, oops, let's put our -4, dot, 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 dot. It just keeps going. It could be infinite number of solutions. This is what we call a solution set. I'm going to add that in here. A solution set. Now this one we have a graph, but we don't have an algebraic notation or words. So we're going to have to figure out the graph first. So we have a 0. Our reference point, our anchor point is at 0. So our solution is going to be 0. Now, it's filled in, so it could be 0, but it also could be anything to the right of 0. So that's greater than 0. So it could be greater than, but it also could be equal. And we can give it whatever letter we want on this one. No reason, I'm going to call it J, just because. So that could be a 0, that could be a 1, it could be a 2, it could be a 3, blah, 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 blah. To put it into words, we would say J is greater than or equal to 0. J is greater than or equal to, I'm running out of room here, 0. We need to make sure that all fits on that box. All right, so there's that one. Now this one, they give us the algebraic description, but not the other three. So this symbol is the same as this symbol, so it's greater than or equal to. So G is, I have to write tiny here since I took up all my space, greater than or equal to -1. So that's our anchor point right here. So we're going to put a circle at -1. Now is that open circle, closed circle? Well, if it could also be equal to -1, we're going to fill it in. It's a closed circle. Greater than means our arrow is going to extend over every value greater than our anchor point. So it could be -1. It could be 0. It could be +1, +2, and so on. All right, our last entry, we have our graph again, but we don't have our other 3 entries here. So our anchor point, our solution is +1. I'm going to put a +1 here. It's not filled in, so it can't equal +1, but that is still our reference point. Our arrow extends over everything to the left, so that's all going to be less than. So we have our less than symbol goes this way. We need a variable, doesn't matter which one. I'm going to pick D. D is less than +1. So that's what we're going to write here. D is less than +1. You don't have to write the positive. All right, so possible solutions for this. Our solution set, could it be +1? No. Could it be a half? Yes, as long as it's less than 1. So we could say a half, we could say 0, -1, and then we could keep going infinitely. And that's how we get our variations of our inequalities.